So the algebraic review, just a quick thing. A radical is any expression with a square root, cube root, etc. We can do fourth roots, third or fifth roots. The radical symbol, we all know what that looks like, right?
Yeah.
A little thing. When we are simplifying square roots, it's important to know what our perfect squares are. We can list out, let's do the first, let's say 20 perfect squares. What's our first perfect square going in numerical order?
2. 1.
1. 1 because 1 squared is 1. What's 2 squared? 4. 3 squared? 4 squared? 5 squared? 6 squared? 7 squared? 8 squared? 9 squared? 10 squared? 11 squared? 12 squared? 13 squared? 169. This is where it starts to get a little bit fuzzy. Where we at? 14 squared. 196. Good, that one is 196. 15 squared. 16 squared.
256.
It is. I knew it ended at a 6. Sorry that 2 ended at 6, but I can never remember the middle number. 17 squared. I think I know this one. Yes? Yeah. And what was that? Was that 18 squared? Oh, was that 19 squared? Where are we at? Alright, so 18 squared. 19 squared. Yes, and then 20 squared. Is that right? 361? I do not have that one memorized. The way these notes set up to write it out isn't the most helpful, as you can see. Another sheet that we can actually use, you don't have to write this down, but it will say 1 squared equals 1, 2 squared equals 4, 3 squared equals 9. This is typically how we write it out. There's a sheet that'll have all that. Just like you have the factor sheet, we can have a perfect square sheet. Okay? When we simplify radicals, what you're doing is you're pulling the perfect squares out. So case 1, it is a perfect square. You just take the square root. Those are the easiest, and you can see like number 1 and number 2, those are perfect squares, and you just give what the value is. The non-perfect squares, says to break the radical down using the largest perfect square, take the square root of the perfect square, and leave the leftover under the radical symbol. The other option is to do the factor tree. Do you guys remember the factor tree? And you get it all down to the primes, and then you look for the buddies. Did you do that in Algebra 1? I like that method because when you get on to finding cube roots, you do that, but now you need triples to pull it off from underneath the radical. Fourth roots, you now need, that's a 4. Fifth roots, 5, so on and so forth. Okay.
For this right here, can you just put it in the calculator? 149 and then you get 7.
Correct. So that's a perfect square where they get that. What we want to do is leave exact answers. So when we get to ones that are not perfect squares, that's where you do the tree. So that you're not rounding. Alright, so looking at number 1, what is the square root of 49? 7, right? When we get into solving, we want the positive and the negative roots. So you'll have to start getting used to writing plus or minus. But if I just ask you what's the square root of 49, you say 7. If you have x squared equals 49 and you're solving, then you get the positive and negative. Alright, what's the square root of 225? 15, good. I'm sorry, what did you say, Kayla? I heard 12, but I touched off. I'm sorry. Yeah, the square root of 144 is 12. So what we can do is go and take the square root. And then what's 2 times 12? 24, right? So that's how you handle that. You simplify the radical first, then multiply it by what's on the outside. Or the coefficient, yeah.
Why did we just multiply by 2? I thought, I just entered it into my calculator and I had 12.
The square root of 144?
Yeah.
Is 12. So we have this 2 on the outside, you get 12 first, and 2 times 12 is 24. But this problem had a 2 in it.
Yeah, what I did was, I introduced my calculator on that.
2 times square root of 144?
Yeah. You get the 12 now.
You did a decimal point, and then you did the x instead of the square root. So, I don't know the decimal point, how I would read that, but you're not taking the square root, you're taking the nth root. And the number before that is what root you're taking. So instead of using that one, use this one.
Oh, wow. I thought you're supposed to use, I thought that's Oh.
Now, if you put the square root of 4 ninths in your calculator, it's going to give you a decimal. We don't want decimals. We want exact answers. So if we do the square root of 4 ninths, we're going to take the square root of 4, which is 2, and the square root of 9.
3.
3, so the answer is 2/3. Again, we want exact answers.
Oh, this one.
I figured this would be, I felt some anxiety in the room, so I thought I'm going to skip and we're going to do something easy. Get everybody back on track. We need a win. All right, number 5, we have the square root of 1 over 81. Square root of 1 is square root of 81. Now number 6, square root of 36 over 121. What would that reduce to? Beautiful. All right, everybody good so far? Now we're getting into the case 2, where these are not perfect squares. This is what we're going to do. Sometimes people call it breaking out of jail. I like to call it breaking out of class. Really nobody gets upset.
Oh, somebody upset with that.
Oh no, I just like to be careful. Alright, so we have the square root of 112. Not a perfect square, so we're going to do the factor tree and get down to the primes. When I say primes, we're looking for your factors. So start with just a pair. What are factors of 112? There's multiple directions we can go in.
8, 14.
8 and 14 sounds good. 8 and 14 are, neither one of those are primes. We're going to keep breaking that down. What does 8 break down to? 4 and 2. 2 is a prime, so I'm going to circle it. So I don't want to forget about it, but I'm going to pause there for a moment. 4 can be broken down into 2 and 2 are primes. I'm just going to circle it so I know that's the end of my tree there, my factor tree. Now I'm going to come over to the 14. 7 and 2, good. Yeah, 7 and 2 are both primes. So now everything circled is the end of my tree. Just a way to stay organized.
Would you do like 2, 2, 2, 2, and then over 7? Or would it be 2, 2, 2, 2, 7?
What we're going to do is we're going to look for buddy pairs. It doesn't matter how they're listed or what order, but if they have a buddy, that means it's a perfect square. If they are a buddy, you put them in one group. When they break out of class, they become one on the outside, so they're bonded forever. So just write that pair once.
Yeah, we did.
Oh, good. And then we have a pair here. And they become one on the outside. 7 does not have a buddy pair. So it stays in jail. I know what pack you're talking about with X on it. Yeah. Good, good. So this will go quick. 2 times 2 is? 4. You get 4 square root of 7. Does everybody remember it then?
Yep.
This will go even quicker. What did we say? 4 square root of 7. Why don't you guys go ahead then and figure out, let's do 8. Just 8 and 11, and then we'll talk about the rest here in a moment. Do 8 and 11.
7 and 5.
7 square root of 5. Good. Maybe we need to see the explanation for that. How about number 11?
5.
You meant 10, right? Did we talk about that?
Oh, are you multiplying that 5 and 2? Okay. Okay, that makes sense.
Alright, now ones that are like, let's do number 9. Where you have a 5 on the outside. We're going to reduce our radical, and then at the end you put the 5 on. Yes, Emma?
I did a little bit wrong. I got 10 and 5. I don't know why.
You did. Wait, what did you do for your factor? Did you do 10 down to. So it doesn't matter which pair of fives. Let me finish circling. It doesn't matter which pair of fives you buddy up. They're going to become 1 on the outside. Then you have a 5 and 2 left over, so we multiply those back together.
Oh, that's what I multiplied the 5 and 2
Gotcha. Alright, so one's like number 9, you're going to do the same thing, but you put the 5, you multiply by whatever's on the outside of the square root of 72. So if we just focus on the 72, what can I break that down to? 8, 9, good. What can 9 break down to?
33.
Those are primes. 8 breaks down to?
4, 2.
Very good, and then 4. Alright, so what are my buddy pairs?
3.
We have 3, and we have a pair of 2s. What's left?
5, 2, 5.
3 times 2.
Oh.
So 6 square root of 2. Or maybe that's
What we do with that 5?
well, let's talk about that. What do I do with that 5 now?
3.
Yeah, so we're going to keep this 5. 5 times 6 is 30 square root of 2. Anybody need to see 10 or 12? Can we start doing the quadratic? Alright, let's look at the quadratic. We're going to do more of these. We got this. Emily? After the x minus 8, x plus 8, so there's another way to do that. This is the other way. So this is a difference of squares, but the other option is to add it to both sides.
Might be 18.
8 and negative 8, you're right.
Oh.
So to take care of the square, we take the square root of both sides. And we have, you can write it as negative 8, 8. You can write it as plus or minus 8. However you want to write that. That's a simple one, where there's no coefficients or anything like that. And it's a perfect square.
I remember doing this.
Good, yeah, this should be easy. That's why I'm rushing it. Alright, number 2 is not a perfect square. Again, think about algebra 1. What do I do first? First, I'm going to handle this 8, though. Yeah, we're going to subtract 8 from both sides. So we get 7x squared with 15 minus 8. 7, good.
Wait. You subtracted 8 by 15. Oh, wait, what?
Yeah, just like remember, you do like minus 8, minus 8. Those cancel out.
Yeah.
7x squared equals 7. Perfect. Now, what do I do? Very good. Divide by 7 and x squared equals. Perfect. Good. This is not a bad section. This should be easy. X squared is equal to 1. What do I do next? Square root it. So what are my 2 values of x? Or my 2 roots? Negative 1 and 1. Good. What's that? Do you want to see some where you have to simplify the radicals?
Yeah.
Alright, let's look at number 6. Number 6, what do I do first?
Minus 30.
Very good. 3 cancel out 9x squared would equal 108. 108 divided by 9. What would I get there? Good. See, now it's not a perfect square, so you're reducing your radical. We're going to take the square root of both sides. So if you want, I heard 2 and 6. 2 and 3.
Wait,
Those are my
so-
friends.
If there's 2 twos off like one, would that be considered a pair?
Yes. That's good.
So these 2 and a square root of 3.
Wait, so the stuff we were learning about in the last packet is what we're doing right now. Why didn't we just start out with this? This is like
I was reviewing, I was going to try to quickly review algebra, and I quickly realized I got to go back further. That's why I reviewed. The only difference is now it's plus or minus 2 square root of 3. Okay? There's the homework. Let's do homework 3.
I like